Hello, I'm Jon Stapleton with CodeVA, and this is a quick tutorial lecture thing about projects as it pertains to computing pedagogy. Let's jump right into it. So coding projects are at the center of computing pedagogy. Many of the project-based learning pedagogical frameworks widely used today have some connections to the computing education community via like Seymour Papert's constructionism concept or Mitch Resnick's lifelong kindergarten play-based pedagogies. There's a ton more out there too. Students complete projects to demonstrate synthesis of coding skills. Well-designed and well-facilitated projects require students to transfer coding skills and knowledge developed in more structured activities and learning experiences to ill-structured, authentic contexts. Projects generally take place over more than one class period and provide ample semi-structured work time for students to experiment, tackle unexpected challenges, and receive individualized instruction. Most of the time, the best way for students to summatively express their coding skills is through a project that produces a program, not through an exam or other quantitative measure. I'm going to unpack some best practices associated with coding projects, as well as some facilitation tips in this video. So first, let's talk about best practices. Here are some starting points. I'm not trying to make a value judgment here or anything. This isn't supposed to be widely generalizable. This is just sort of like, basic ideas about what effective project-based learning looks like. So first, projects should be personally relevant. I'm going to go slightly out of order here. Projects should be personally relevant. Projects should be relevant to students' interests, engaging their prior interests, goals, needs, and desires. Educators might create projects that engage with the student's cultural identity, like, for example, in the context of culturally responsive sustaining pedagogy. You could engage with their prior interests, like through interest-driven learning, or prior knowledge, like having students work with projects that engage with a subject area they already know about. Personal relevance, right? That students find themselves in their projects. Projects should also be open-ended. Right? Programs need to be project prompts should be flexible, allowing for multiple creative interpretations. Open-ended project prompts allow for students to self-differentiate, where they can commit to goals with support and guidance from the teacher, suited to their level of understanding. One good way to measure the quality of a project prompt is by how many different kinds of results students produce. If everyone's project is the same, the project may not have required much skill transfer or concept synthesis, or may not have had space for each individual student's goals to be expressed. And finally, projects should be relevant to content, most of all, right? Projects must be relevant to the content you're interested in assessing. Crafting prompts that meet this requirement is not all that difficult. In fact, if you're in a programming course, you can look back and kind of use projects and other prompts in there as models. But creating prompts that engage with standards-aligned coding skills while also meeting other criteria like open-endedness or personal relevance can be tricky. As students design projects to address personally relevant and open-ended prompts, it's a good idea to provide feedback to make sure they can create a project that demonstrates the skills and knowledge that you need to assess. It's got to be open-ended, it's got to be personally relevant, and hopefully you can kind of help them connect it to the content they need as well. As far as facilitation tips go, I have a couple of strategies that are worth thinking about. There's a lot of other strategies out there, so don't take this as an exhaustive list. You can use this idea called choice scaffolds. Instead of asking students to come up with what they'll make for a summative project, offer students choices that meet the content requirements you'd like their projects to align to. You can have lots of choices that align to different personal interests that students can commit to in various degrees. Students can choose from among the options. They can create a modified version of one of the options, or they can create their own original option using the provided choices as a model. So there's lots of ways to use those choice scaffolds, and students can claim different levels of agency in those choices, depending on how you use it. You should also provide code examples of projects. Examples of projects that align to content objectives of the project prompt can help students identify what sorts of projects are in scope for a given prompt. It's okay for students to use these examples as models for their own code as long as you discourage them from designing a project that's too similar to an example. Transferring concepts from a code example to an original program is really important and a really good skill to learn. There's no reason to expect students to develop enough fluency to write code from memory over the course of a single unit or something like that. It takes a long time to develop the fluency to sit down with an empty file and just kind of crank out a program. There's also some structure ideas that you should take into account. You shouldn't have students grind away at their projects in silence over a week or 2 weeks of instructional time. You should provide milestones to help students pace their work, break up project time with collaborative activities and collective learning experiences. Code review, pair programming, and individual feedback can help provide scaffolding for open-ended project prompts, giving students really important feedback to help kind of help them align their goals with content objectives, and also kind of align their goals with mental models of what the computer can do. Individualized instruction is also super important in projects. During project work, students will require individualized instruction to address the unique challenges they encounter. Plan on modeling debugging practices, even if you know exactly what's wrong with students' code, and conducting formative assessments during that project work. Consider setting up a peer coaching protocol to avoid being pulled in 20 different directions, helping students troubleshoot. You want to kind of maximize your impact in those individualized instruction moments. And finally, you need to assess students' work. There are a lot of options out there. Reading students' code is one good strategy, but you'll often find other strategies to be a better use of your time. Consider having students do like a code walkthrough after they finish their work. You can have them set up a screen recording and have students speak about their code and respond to reflective prompts. They can kind of like scroll through their program, explain different chunks of it, explain challenges they ran into, and that way you get to see their code, but you also get context around that code from the student. You can also have students conduct peer feedback or assessment in gallery walk format. Definitely don't use students' assessments of one another as a grade. That's not good. But instead, use the feedback a student is providing to provide insight into that student's own knowledge. For example, can that student identify how another student used conditional control structures? Can they give feedback on that? Because if they can, they probably understand that concept pretty well. There's some examples that I've provided here. They're linked over there, but you can also find the links in the description. You can kind of see some different ways of approaching projects to have them be open-ended and meet some of these criteria. If you have questions about this stuff or comments or really anything, we'd love to hear from you. Get in the comments of this video. Otherwise, good luck and happy coding.